Hello everyone. Now let's look at the last question of our midterm test, question 11. This question is on sampling distribution of sample means. This topic is covered in our lecture 6, which is the last lecture before the recess week. So let's look at the question itself first. So in this question, we are given our population distribution. So the distribution is given in the form of a table. The first row is possible values of x, and the second row are the probabilities. When x is equal to -2, the probability is 0.2, and 0, 0.6, 2, 0.2. Okay, and also we are also given that when we sample the population, the sample size is 2, and we are sampling with replacement. And moreover, we are not given any information of the population size. That means we can safely assume this is a large population, and we don't have to consider the finite population corrector so far. Okay. So part A, we are required to find the sample distribution of sample means. In part B, we are required to calculate the expected value or the mean of the sample mean. And in part C, we are required to calculate the standard error. And for part D, now in part D, we are given the population size. Population size is 5, and we are sampling without replacement. So you may think of considering finite population corrector. So if population size is 5, will our answers to A, B, and C change or not? Okay. Now let's try to solve these 4 parts one by one. If you recall, this question is actually very similar to the example given in our lecture. There are 2 observations, right? So there are different possible combinations of the sample. So the first observation, we may get -2, we may get 0, we may get 2. Okay, this is the first observation. Then for the second observation, we may get -2, we may get 0, and we may get 2. Okay, so if our sample is like -2 and -2, the sample mean will be -2, right? So this is a sample mean, and in this case, the sample mean will be -1. In this case, the sample mean will be 0, right? So in the same way, we can get the sample means of all the possible samples. This one, -1, 0, and 1. And this one, 0, 1, and 2. Okay, these are the possible sample means. Now the next step, we need to find the probabilities. Okay, for example, when our sample is -2 and -2, what is the probability? Okay, so we go back to the table given in the question. -2 and -2, the probability will be 0.2 times 0.2, right? So the probability 0.04. Okay, in the same way, we can find all the probabilities for the possible samples. So for this one, 0 and -2, we'll get the probability of 0.12. 2 and -2, we'll get 0.04. So -2, 0, 0.12, 0 and 0, 0.36, 2, 0, 0.12, -2, 2, 0.04, 0 and 2, 0.12, 2 and 2, 0.04. Okay, so we now have all the probabilities of all the sample means. The next step, we want to report our probability distribution of sample mean. Okay, so as we can see, the possible values of sample means are -2, -1, 0, 1, and 2. Then what are the probabilities? So the first one, -2. Let's go back to our table here. So we have -2 here. Okay, this is the only -2 we have. So the probability will be 0.04. Okay, the second value, -1. So we go back to our table. We have -1 over here and -1 over here. Okay, then the probability will be this value plus this value. Right, that means we have 0.24. For 0, we have three zeros over here. Here, here, and here. We sum over these three values, we get the probability, which is 0.44. Okay? Then in the same way, we get the probability for 1, 0.24, and the probability for 2 is 0.04. Okay? So this table here will be the probability distribution of sample means. That is also the sampling distribution of sample means, which is the answer to part A. You can double check if your answer is correct. If you sum over these values, 0.04, 0.24, 0.44, 0.24, 0.24, they should sum up to 1. Okay? So this is a solution to part A. Okay, now let's look at part B. We are required to calculate the expected value of sample mean. Okay, so this is what we are trying to calculate. So from part A, we have obtained the sampling distribution of sample means already. So we can proceed from there. This is a discrete random variable distribution. So if you recall the formula, you can find this formula from the formula sheet. Right, this is how we calculate the mean of a discrete random variable distribution. So this is a variable, this is a PDF. So over here in this question, our variable is sample mean, and this PDF is just a table we have obtained from part A. So we can substitute the values into this formula. That means it's 0.04 multiplied by -2 plus 0.24 multiplied by -1 plus 0.44 multiplied by 0 plus 0.24 multiplied by 1 plus 0.04 multiplied by 2. Okay? So if you calculate this is equal to 0. As you can see, this is a solution for part A. This is a variable, this is a PDF, then variable multiplied by probability, variable multiplied by probability is just over here, same as this equation. So it is equal to 0. There is a second approach to do this question. If you recall our lecture 6, we know a relationship between the sample mean and the population mean, right? We have this formula over here. Okay, so the expected value of sample mean is equal to the population mean. And in the question, we are given a table. Remember that this is a population distribution. That means if we can calculate the mean of this population distribution, that is actually mu, it is just equal to the value we are looking for. Okay, so in the same way, discrete random variable probabilities, so minus 2 times 0.2 plus 0 times 0.6 plus 2 times 0.2, it is equal to 0. Okay, you can compare these two approaches. Both of them will give you 0. So this is the first approach. We proceed from the table we obtained from part A, and this is a second approach. We make use of the relationship between sample mean and the population mean. Okay, so this is a solution to part B, and the answer is 0. Okay, now let's look at part C. So in part C, we want to calculate the standard error. Okay, so in part C, we want to calculate sigma x bar, which is a standard error. There are also two approaches for this question. Okay, so first of all, we want to use a relationship between the population and the sampling distribution of sample mean. So if you recall, we have this relationship, that is standard error squared is equal to the population variance divided by the sample size. Okay, so from the question, we know the sample size is 2. So we can just calculate the population variance sigma square, and we can get the standard error. Okay, so we go back to the table in the question. This is a population distribution. So now we want to calculate the variance of this distribution. So if you recall, we have this formula. The variance is equal to squared multiplied by the probability of x. Okay, so now we substitute these values into this formula, then we can get sigma squared, which is a population variance. Okay, that means minus 2 minus 0. Because from part B, we know the population mean is 0. Then we take the square, multiply by 0.2 plus 0 minus 0 square, multiply by 0.6 plus 2 minus 0, take the square, multiply by 0.2. Okay, so if you calculate it, this value is 1.6. Okay, that means sigma square is 1.6. So the standard error square is equal to 1.6 divided by 2, and the standard error will be the square root of 1.6 divided by 2, square root of 0.8. If you use a calculator, the square root of 0.8, that is 0.8944. Okay, that means the standard error is 0.8944. This is the first approach. We also have a second approach. Okay, so if you recall, this standard error, it is actually the square root of the variance of sample mean. That means if we can calculate the variance of sample mean, we take the square root, we can get this standard error. And how do we get this variance of sample mean? From part A, we know the distribution of sample mean. So from there, we can derive the variance and also the standard error. Okay, so this is a distribution of sample mean. So by the same formula, we can compute the variance of sample mean. So we substitute these values into this formula. It will be -2 -0, because from part B we know this mu is also 0. Okay, 0.04 plus -1 minus 0 square, 0.24 plus 0 minus 0 square, 0.44 plus 1 minus 0 square, 0.24 plus 2 minus 0 square, 0.24. Okay, so if you calculate it, this will be 0.8. Okay, so now we just take the square root of 0.8. This value will be the standard error. As you can compare with the previous method, it is a same value. Okay, so in the first method, we use a relationship between the standard error and the population variance. Okay, in the second method, we use a definition of standard error. Okay, and we get consistent result. So this is part C. Okay, now let's look at part D. So in part D, we are given the population size. Population size is equal to 5. And also, we are going to sample without replacement. Okay, so the population size is equal to 5. This means that now we have only 1 -2 and 3 0 and also 1 +2. Okay, this is according to the population distribution given in the question. Okay, and sampling without replacement, that means for -2 and +2, when we sample, these two elements can only be used once. Okay, so the possible samples in this case will be -2, 0, 0, 0, +2, 0, and -2 and 2. Okay, these are the 4 possible samples of this population. So now we want to compute the probability of getting these 4 samples. We'll use this method. Okay, the denominator is total number of ways of getting a sample. That means we have 5 elements and we'll select 2 from this 5. So in the numerator, we are going to compute the number of ways that satisfy a certain requirement. For example, if we want to get the first sample -2 and 0, we need to select the only -2. And also among these 3 0, we need to select 1. So this is the probability for getting this sample. Okay, so this is actually equal to 3/10. So in the same way, we can calculate the probability of getting this sample, the second sample, that is, so among 3, we select 2, divided by the total number of ways. This is also 3/10. Then for the third sample, it is actually 3/10 if you use this method. And for the last one, it is actually 1/10. Okay, so we can fill in the probabilities for this one. This is 3/10 for the second one. This is 3/10 for the third one, 3/10. Last one, 1/10. Okay, so now we can get the sample mean distribution. Okay, so as usual, we'll have sample mean. The possible values will be -1, 0, and 1. Okay, and also the probability. So for the first value, -1, we can get from this sample -2 and 0. Okay, so the probability will be 3/10. That is just 0.3. Okay. For the second value, 0, we can get from this sample and the fourth sample. Okay, so that is 0.3 plus 0.1, that is 0.4. Okay, then for the last value, 1, we get from this sample. Okay, so the probability is 0.3. Okay, so this is actually our new sample mean distribution. These 3 are the possible values of sample mean, and 0.3, 0.4, and 0.3 are the probabilities respectively. So if you compare with the answer in part A, obviously it is a different distribution. Okay, so now part B, does the answer change or not? So by looking at this distribution, we know that the mean value is still 0. So for this one, there's no change. But for the standard error, because we have a sample size which is 5, the population size is 5 and sample size is 2. So it is a large sample relative to the population. So in this case, we need to consider the finite population correction factor. Okay, if you refer to the formula sheet, we have this formula with the finite population correction factor. Okay, so square. So the new standard error is actually this one. This part is the old standard error. it's actually square root of 0.8, and for this part, this is a correction factor, so it's 5 minus 2 over 5 minus 1. Overall, we'll get square root of 0.6. Okay, this is 0.7746. Okay, so this will be our new standard error. Okay, so overall for part A and part C, the answer have changed, and for part B, the answer has no change. Okay, so this is question 11. Thank you for watching and have a nice week. Thank you.